Hi, I'm Joey, and me and my partners Will and Devin will be discussing our project on neural networks making the ethical decision of going to war. So just a quick project overview. Our main question is, should we go to war as a nation, the United States? And our output for that will be yes or no. And basically, we have already designed a successful neural network in doing that, in which we used questions, 10 questions that we tested multiple times, put in the neural network, and it gave weights for each of them. So we implemented this code and project in MATLAB. So the first article we'll go over in the literature review was Just War Moralities by Gabriel Palmer Fernandez. And basically it talked about different Latin phrases, jus ad bellum, jus in bello, ad bellum, and they have different definitions. And essentially he went into really what this means as far as going to war and the ethical and moral implications. For jus ad bellum, there needs to be a legitimate, competent authority declaring war. There needs to be a just cause for initially going into war, as well as the right intentions as far as outcome, like peace should be a right intention. There's 3 points of view of war we can also look at when trying to determine our questions and how a neural network should answer. There's the pacifist view, the just war view, and the realist view. And basically the pacifist is against war and violence in any way. Realism is just taking something as it is and taking necessary action because of it. And just war happens to be somewhere in between there. And so lastly, jus in bello is right conduct in war, so it talks about non-combatant immunity, and we need to make sure that the benefits anyone gains aren't too difficult to identify, that there's legitimate benefits that each side is going for going to war. Finally, ad bellum is the moral priority of nonviolence over war. So really we should be going for nonviolence if at all possible, but if we have to go to war, then we will. The next article was on Kant's just war theory and his ethics of war and peace. Kant was an 18th century philosopher, and essentially he talks about the same things the previous article did with jus ad bellum as well as jus in bello. However, with ad bellum he adds principles of last resort, that war should be a last resort among everything. Negotiations should be attempted. Comparative justice, that different sides are going to have different views of justice in their mind, and that we need to be aware of that and compromise where necessary. And finally, perpetual peace. Peace should be the outcome of war and a long-lasting peace. And jus in bello, he adds the principles of discriminacy and proportionality within war. And finally, just post bellum is one he takes more time, kind of something he made his own, and talks about the justice of the move from war back to peace. So these are our top questions in which we actually tested in Excel, just using a random number generator, giving us a bunch of ones and zeros for each. And we did 150 of these, and basically, based on our own judgments, we decide whether we should go to war or not as an output, 1 or 0. And so some of our good questions are the first one: if we do not go to war, is the estimated loss of combatant life minimal? Rather, if we do go to war. Another one that was highly weighted: is it a human rights war? Like, are we freeing a country from tyranny or social justice? Others include like loss of civilian life. Is there an imminent threat to that? Or if we don't go to war, is there a loss of civilian life? Is that a potential option? And then also, did we try solutions like negotiations, nonviolent solutions? And lastly, does the outcome of war set a precedence for future peace? This is definitely one that was weighted very highly as we were going through the questions, because peace should be the ultimate goal of war.
And here we have our diagram of our neural network featuring MATLAB. We use a 2-layer feed-forward network here with a sigmoid hidden and softmax output neurons. The term feed-forward refers to just how the neural network is interconnected, so each layer feed-forwards to the next. And so we start with our inputs of 1 and 0s, go to the hidden layer, to the output layer, and then we receive our output of either a 1 or a 0, and a percentage of whether or not we should go to war or not. And here we have our matrix formulation. So we start with our inputs, where we have our answers to the 10 questions that we formulated. So we have 150 different randomized scenarios, and then we basically just answer the 10 questions for each scenario. However, for our first 5 scenarios, we based these off actual wars the U.S. has fought in. So for the first one, we have World War II, then the Civil War, Vietnam. This one, we did North Korea in our current time period, so if things escalated, what might be our inputs for that. And then we ended with the Middle Eastern Iraq War. And so we, based off the ones and zeros, we decided if we should go to war or if we shouldn't. And these are just based off the question. So this isn't necessarily what the U.S. should actually do, but based off these questions, this is what we should have done. And then we formulated a 10 by 150 X matrix that we input for our inputs. And then we have a 1 by 150 Y matrix that we use to basically just answer our questions and train our neural network.
At this point in the video, I will now be going over our MATLAB demonstration. So for this project, we used MATLAB's neural pattern recognition application in order to train our network and then eventually test it and generate code for it. There's that same diagram of the neural network on the right-hand side of the screen. And this is just a welcome page that kind of tells you about the neural network and how it works. So if you hit next, you'll be taken to a select data page where you can put in your inputs and targets. And in our case, we have X for our inputs, which is the matrix that we put in before for the answers to our 10 questions. Then we have the Y matrix for our targets, which is the 1 by 150 matrix representing the answers to our question, should we as a nation go to war, yes or no? And notice how we have our samples and matrix columns at this time, because we have 10 questions by 150 tests, and then we have one answer or one question, should we go to war or not, and again by 150 tests. Notice if we put this the samples in matrix rows, we'll get an error down here from MATLAB saying data selections have different numbers of samples, select columns orientation. And what it's saying is 10 samples of 150 elements. That's not right, because we only have 10 elements for our inputs and 150 samples, and then one element of 150 samples for our Y targets. So that's kind of a nice feature that MATLAB has that kind of tells you if you have it in the right orientation. But again, the summary, as I explained before, should kind of give you an idea of whether or not you're in the correct orientation. So now we can move on to the validation and test data page. We can change these percentages to divide up our 150 samples, but the default percentages are 70% for training, 15% for validation, and 15% for testing. And so notice that if you change, for example, the validation category to 25%, then the other two categories, or rather the training categories, automatically change based on what these two categories here are. And then you can always click on Restore Defaults to take you back to the 70, 15, 15. But for our case, we're just going to use the default percentages and can go ahead and move on to the network architecture page. So on this page, we can define how many neurons, hidden neurons, we want in our network. And the recommendation on the right tells us that we can return to this panel and change the number of neurons if the network does not perform well after training. Our group decided to test 10, 8, and 5 neurons and found that 10 allowed our network to perform the best. So we're going to go ahead with 10 matrices, or 10 neurons, but we can go ahead and change that at a later time if we so please. So now here we have the train network page, and this allows us to simply click train, and this trains our network, and we can always retrain it. But if we plot our confusion matrix, we can see the different percentages for how our network is actually performing, and we're actually interested in the blue squares here, 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 and here. And these matrices are for training, validation, test, and then all. And these are actually pretty good percentages that we have here, and they're similar to the one that will be shown in the PowerPoint. And these are probably pretty accurate. Sometimes you'll get 100% in a couple of them, which is kind of strange because if your neural network is 100% accurate, either you're really, really good, or you probably have some type of error where your network is actually not performing correctly. But this data looks actually pretty good, so we can go ahead and close out of here. And if you didn't like what you're getting there, you can always retrain the network. Say you're getting like 60%, 70%, so you want a little bit higher, like 80s or 90s, like we just had. Then you can go ahead and press retrain. But otherwise, you can once you're satisfied, you can go ahead and click next. And this evaluate network page just kind of lets you kind of adjust the network and allows you to put in different inputs and targets, train again, adjust the network size, and so forth. But then we can go ahead and get our deploy solution page, and we want to generate code so that we can input our own scenario and have the network tell us whether or not we should go to war or not. So basically all we have to do is press this MATLAB matrix only function. I'm not going to press it at this time because we already have our function, but that is what you would do to generate code. And yeah, so that's our neural pattern recognition application. So now that we're back to our PowerPoint, I kind of explained the confusion matrix a little bit earlier, and here's the data that we got previously, and this seemed to be the best that we were coming up with, but as you can see in the video, we even got better results. We trained our network again, but these are actually pretty good in the 80s and 90s. And over to the left, you have a little bit of a description again about what the confusion matrix is and kind of how it's being used. So now we have our Revolutionary War example. This is the example that we're going to show how our network works and how it runs through the code basically to give us an answer. So here are 10 questions, as you can see on the left-hand side of the screen, and here are the answers that we came up with for each of those questions. And as a group, we decided yes, we should have gone to war in that situation. And as will be shown in the demonstration of this particular example in our neural network will spit out a percentage of whether or not we should go to war or not. So here's the MATLAB code for our neural network. It's not super long, but it does have a decent amount of detail to it. So simply we just have to put x1 equals, and then here are the answers to our questions about the Revolutionary War that we went ahead and put in as a matrix. And we have our war network of x1, as you can see up here. And if we go ahead and run the network, run the code, we can see that it gives us an answer of 1, meaning we should go to war, and we also put the answer in a percentage, meaning that there is a 77% chance that we should go to war. So not 100%, but that's just how our network works, and so in this situation, most likely the nation would want to go to war. And I'll let you pause the video if you care to look through some of the more detailed parts of this code. But for now, I'm going to move back to the PowerPoint, and we can go over a few other things there.
And here we have some of the implications of our neural network. We found that our neural network was efficient in predicting decisions of war that are simple and more basic scenarios, as opposed to more complex situations with many other factors that can really just make the decision much harder to make. Some of these examples of complex factors include treaties and alliances amongst countries, as well as time of involvement, which can be difficult to predict. An example of this being the Iraq War, where we thought we'd be there for just a few years and it ended up being over a decade. Another implication is that the different types of wars require different decision-making processes and inputs. An example of this is being civil wars that can often be a lot more complicated in making the correct decision. We will finish our presentation by going over a few conclusions that we've made throughout this process. Declaring war affects the lives of millions of people, so making the correct decision in real life scenarios is vital. And so declaring war can be very difficult to predict, as many factors regarding war are very complex. Examples being our input questions of how many lives are lost and how many lives would be lost if we don't go to war. So these are just very difficult to predict prior to declaring a war. So maybe it wouldn't be the best questions to ask. But although we attempted to summarize the factors going to war with our input questions, just the fact that going to war is complex means careful consideration and time is needed in order to make the correct decision. And here are just some of our references, and thank you for watching.